the remainder of this unit is all about understanding what polynomials, so y equals 2x cubed plus x squared minus 72x minus 36 looks like. Okay? We already know a little bit about what it looks like, because we know the degree and we know the leading coefficient. What do we know? Mr. Clark, what do you know? What do we already know? We talked about this last unit in terms of how that graph looks like. Two x cubed plus x squared minus 72x minus 36. You know a little bit about what it looks like. What do you know? You know, Ms. Birch? What do you know? Ms. Chisholm, you know anything about that graph? Oh, what's that? Yeah. Why do you know it's going to be like this? It's a cube. You know it'll end up like that and like that. That's cool. Okay. Do you remember that, Mr. Quinn? Sorry, yeah. From last unit? Any odd function will have end behavior like this if the leading coefficient is positive. Every even function will have end behavior like this. Or you could flip them if it's a negative leading coefficient, right? Okay. But now, through our knowledge of factoring, we're going to be able to figure out more stuff. Okay, here we go. Let's factor 2x cubed plus x squared minus 72x minus 36. Two x cubed and negative 72x. What do they share? X squared and 36. Mr. Quinn, what do they share? Just be 1. Very good. Mr. Irwin, 2x cubed and x squared. Mr. Garcia, tough one, negative 72x and negative 36.
30. No.
Yep. 36. Now, positive or negative to make sure things are lined up. 2x times 36 is not negative 72x. That needs to be a negative 36. That needs to be a negative 36, okay? I hope we check this on our quiz, making sure signs worked out. If we distributed things, they should work out. Okay, so I can factor this to be 2x plus 1 times x squared minus 36. Is there more I could do? What is that, Mr. Sharipata? I think you have the right idea. X squared minus 36 is a difference of squares. This is x being squared, and this is 6 being squared. It's a difference of perfect squares. So this is 2x plus 1. This is x plus 6 times x minus 6. Difference of squares. Okay. If I have a factored form, 2x plus 1 times x plus 6 times x minus 6 equal to 0. Ms. Abernathy, what do I know? What do I know? Ms. Abernathy, if I add this equal to 0, do you remember when we solved equations quadratics and we had factored forms equal to 0 like this? What did I say my solutions were? When is the left side equal to 0? Okay. When, for what x values do I plug into the left side so that I have a 0 y, so that I have the 0? What makes this 0? What makes this 0 for x? -2 and -3, right? Okay, well, we figure out then when x is -6, when x is +6, and what would be when this is 0? -1/2. We actually know the zeros for the graph. So we already know that we're going to end like this. Let's first remember that. But then we also know that we are going to cross through the y equals x-axis at -6, at -1/2, and at 6. At least that's what we think we'll always do. So we end up like that. Well, they graphed that for you already. Here's the graph of that polynomial. Okay, this is the graph of y equals, oh my goodness, I'm going to flip out on you for just like being really out of it today. This is y equals 2x cubed u2 plus x squared minus 72x minus 72. Sorry, minus 36. This is that graph. The end behavior we already talked about, we got it. But notice, we have zeros. So we know more information. They are the zeros of the function or the x-intercepts of the graph. Cool. Everybody have a graphing calculator? Make sure you have a graphing calculator for the remainder of class. Okay. Now let's look at this guy. 2x cubed minus 12x squared plus 18x. We're going to factor this. Step 1, greatest common factor. 2x. Write down what's left over. Everybody. X squared. We get an x squared. We get a negative 6x, and we get a positive 9 equals 0, right? Okay, now I have three things. It's just an x squared. Number puzzle. What two numbers multiply to get 9, add to get negative 6? Miss Fabregas. 3 and negative 3 would add to get 0. Yes, they're the same number, negative 3 and negative 3. Thanks for the assist there. Okay, now, let's look at this. what numbers can be plugged into the left side so that the entire left side equals 0? 0 is one of them, and this is very important. If I plug in 0 here, or 0 everywhere, this would be 0 times something times something. 0 times anything is 0. 0 is one of them. What's the other one, Mr. Quinn? What is the other number I can plug in to get a 0? Mr. Steck, give him an assist. 3. Thank you, Mr. Steck. Now, it looks like we have 3 that can go in twice. And if you actually wanted to rewrite this, you could do 2x times x minus 3 squared. So it looks like we have 3 twice. Now, everybody please graph this. We think about zeros as situations where you pass through the x-axis, right? So I know I have a 0 at 0 and at 3. What is my end behavior of this graph, Mr. Berneberg? 2x cubed minus 12x squared plus 18x. What would be the end behavior? Use your arms. That'd be negative 2x squared, 2x cubed. That would be positive 2x cubed. Here's my end behavior. What's the problem here? I can't go through 3 and then come back up. Right? Because then I'd have another 0. But I only said I only have 2. Everybody please graph y equals 2x cubed minus 12x squared plus 18x and tell me what happens at 3? We have a situation that we're familiar with, like with y equals x squared. We can have a situation where we just touch the x-axis and then come back up. That is shown on the graph here. If you didn't graph it because you're lazy and you're not doing anything in class, you can look at the graph right here. This is the graph of y equals 2x cubed minus 12x squared plus 18x. We notice it goes through at x equals 0. But then at x equals 3, it just bounces off of it. Okay? In this example, the factor x minus 3 occurs more than once. This creates a repeated solution of x equals 3. This is called a multiplicity. 3 has a multiplicity of 2. The graph touches but does not cross the x-axis. Now, let's graph something where I'm just going to give you factored forms, okay? This is going to be easy, okay? I'm going to look at 2, 3, and 4. X minus 2 times x minus 3 squared times x minus 4 cubed times x minus 5 to the 4th. Please, everybody, graph this in your calculator. Okay, I'd like you to do something for me. Adjust your window so you're going from 1.5 to 5.5. And so you're going from -2 to 2 for your y's. Nope. As long as the min is less than the max, you're good. Okay. If I set this equation equal to 0, we have 2, 3, 4, and 5 as solutions. I would say 2 has a multiplicity of 1. I'm going to put m equals 1. I'd have 3 has a multiplicity of 2 because I have x minus 3 twice. I have 4 as a multiplicity of 3, and I have 5 as a multiplicity of 4. Okay. What happens at x equals 2? We go straight through. What happens at x equals 3? It bounces off. What happens at x equals 4, where the multiplicity is 3? Does it go straight through? No, it slows down, and then it passes through. What happens at x equals 5? Well, we end up bouncing off there when the multiplicity is 4. Okay? If your multiplicity is even, like 2 or 4, you're going to bounce off the graph. The x-axis, that's what I meant, not the graph. If your multiplicity is odd, and your multiplicity is 1, which is an odd number, you're just going to go through. But if your multiplicity is 3 or 5 or 7 or any other odd number, you're going to end up slowing down and bending through the x-axis. M equals 1. This is 3 or 5 or 7. Okay?
What is the top one to bounce off?
Bounce off the x-axis. Sorry for my penmanship. Thank you for asking. Okay? So, ready? You're asked to solve this. Okay. It shares a 3x cubed. Great. I got x squared. I got 6x. And I got 9. I got 3x cubed. The two numbers that multiply to get 9 and add to get 6 are 3 and 3. This could be written as 3x cubed times x plus 3 squared. The numbers that can be plugged in to make the left side 0 are 0 and -3. I'll let everybody catch up. Now, 0, if I plug 0 into x cubed, it's 0, but I see it's cubed. This is why I say this multiplicity equals 3. Since this is an odd multiplicity, I'm going to bend on my way through. -3, if I plug in -3, I see it's x plus 3 squared. -3 has a multiplicity of 2. If your multiplicity is even, what do you say? X plus 3 squared. Or x plus 3 times x plus 3. Ms. Harvey, what do I say if my multiplicity is even? Look at the last page of your notes that we just filled out. And if you fill them out, you have the answer. If your multiplicity is even, what happens? It bounces. Thank you, Ms. Harvey. If your multiplicity is even, we are going to bounce. This is the graph of y equals 3x to the fifth plus 18x to the fourth plus 27x cubed. You could graph this yourself and see at x equals -3, we bounce. At x equals 0, we bend. We already know the end behavior of the graph because it's an odd power with a leading coefficient that is positive. We know it's going to look like this, but now we know how it's probably going to be shaped. Now, one thing that is extremely important is if you have a specific degree of a polynomial, you are guaranteed to have a same number of zeros if you count the multiplicities. A fifth degree polynomial will have 5 zeros, including the multiplicities. Now the zeros could be real or imaginary, and we will get into in later classes in this unit imaginary solutions and what that looks. A third degree polynomial is going to have 3 zeros, including your multiplicities and including real and imaginary solutions. What was this type of function? A fifth degree. How many zeros did I have, Ms. Wenson? Two. X equals 0 and x equals -3. Those are 2. But 0 happened 3 times. -3 happened 2 times. 3 plus 2, 5. Has to happen. This is a fundamental theorem of algebra, they call it. Okay? So when we do our problems, we're going to know and guarantee that we're going to have a certain amount of solutions. Okay? Let's take this. Ready? Last one. Mr. Garcia, since you've already packed up, tell me what would be the first thing to factor when I'm factoring -4x cubed plus 64x?
-4.
Very nice. -4x comes out. What do I have left over?
X squared plus 4h. X
16. You would use your calculator for that. This could factor to be what, Mr. Quinn? X squared minus 16. How do you factor x squared minus 16? Oh boy, it's a rough day. Miss Abernathy, can you help him out again? X plus 4, x minus 4. Miss Viamore, what are my zeros? You're already standing up. Nobody's leaving. Nobody's getting past me until we answer this. What are the zeros? And there's another one. Miss Crabtree, what's the other one? You know you're going to pass through that, pass through that, pass through that. The multiplicities are 1. More factoring, more solving next class. Thanks. x, 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 x. If I multiplied this out, this would be an x to the fourth. So this would be a fourth degree polynomial. Fourth degree, I know the end behavior looks something like this with a positive coefficient. The zeros are at x equals -2 and x equals 3. -2 has a multiplicity of 2. 3 has a multiplicity of 2. That means I'm going to bounce off of -2. I'm going to bounce off of 3. And there's my answers. Even, odd, it's an even, it's a positive or negative, positive leading coefficient. Okay? Here. I factored this. It becomes -2 times x minus 4, x minus 4, x minus 4. X equals 4 is the only solution. Its multiplicity is 3. That's telling me I'm going to bend. I got a negative value, and if I multiply all these x's out, it would be -2x cubed. End behavior of a negative x cubed is like this. I'm going to go through -4, and I'm going to bend as I get through it. So something like that. If I'm giving you a graph, you should be able to write the equation for it. Well, a possible equation, I can see this is an odd. I can see I pass through x equals -1 as a solution, and x equals 2 as a solution. Well, for x equals -1, x plus 1 must be the factor, and this would be x minus 2 must be the factor. But I notice that it bounces off, so that'd be 2, and it goes straight through, so this would be 1. So my factored form of this equation would be x plus 1 squared times x minus 2. The standard form, now this is going to take a while, we're going to have to multiply this stuff all together. Now the only way we can do this is just one at a time. So x plus 1 times x plus 1 is x squared plus 2x plus 1. And you take that and multiply it by x minus 2. If you want to, you can use the box method. You got x cubed, -2x squared, 2x squared, -4x, x, -2. Your standard form would be x cubed minus 3x, because the 2x squareds are gone, minus 2. Okay, so I can take this factor, it turns into this, and then I can go from there. Given a polynomial with a 0 at 2, so x equals 2 is a 0, and a repeated 0 at -5, so -5. This multiplicity would be 1, this multiplicity is 2 at the simplest polynomial. Well, y would equal x minus 2 must be the first one, x plus 5 must be the second one, but it's a multiplicity of 2, so I'm squaring it. I got to find standard form. I need to square x plus 5, x squared plus 10x plus 25. Then I need to take x plus 2 and multiply it, or x minus 2 multiplied by that. I get x cubed, 10x squared, 25x, -2x squared, -20x, -50. This is x cubed plus 8x squared plus 5x minus 50. Okay, that's it. We'll stop at that one.